All right, so continuing to look at factoring. So now we're going to look at factoring. What happens if you have a formula or an equation in the form x squared plus bx plus c? First thing we would think about is what type of problem would give us this as an answer. So I am very familiar with foiling, so I know when I foil, when I have a binomial times a binomial, this is what I get as my answer. So if we think that factoring, the goal is to get a multiplication problem, if I have a problem that looks like this and I'm asked to factor it, I know the answer I'm going to get is a binomial times a binomial. As I've said before, I'm going to give you guys a flow map that's going to show you what process you can be taking or should be taking when you're factoring. And so now we've learned that step 1 to check, is there a GCF? If yes, factor it out. Step 2. Do you have a perfect square minus a perfect square? If yes, use a formula. Remember, there are other formulas to look for as well. A squared plus 2ab plus b squared, or a squared minus 2ab plus b squared. So if you answer no to number 2, move on to number 3. Do you have a trinomial, so 3 terms, the first term being x squared with a coefficient of 1. So you don't have 2x squared, you don't have negative 3x squared, you just have x squared. If yes, you're going to use this next method, which is a factor sum table. Here are your steps for a factor sum table. Step 1, you're going to set up for a pair of binomials multiplying with parentheses and put an x in the front of each one. Then you'll make a factor sum table where you'll do factors of the last, which is your constant term, with a sum of the middle, which is your linear term. So you do have to make sure that your problem is in standard form, meaning your exponents descend. So x squared, x to the 1, no variable with an exponent. From your factor sum table, you're going to put the numbers from the table into your parentheses. So let's go ahead and look at what this would look like. So looking at the first example, so first thing I ask myself, is there a GCF? No, there's nothing all 3 terms can be divided by. Do I have perfect square minus perfect square? No again. Do I have a trinomial with an x squared and a coefficient of 1? 1 term, 2 terms, 3 terms. Yep, I got a trinomial. Yep, it starts with x squared. Yep, it's just 1x squared. So I'm going to go ahead and I'm going to use these 3 steps here. So I'm going to start by recognizing that this is going to factor into a product of binomials that each start with an x. And then I'm going to make a table where I'm going to try to find factors of 21 and a sum of 10. The purpose of this table is for you to do some guessing and checking. So maybe I say I know 1 times 21 is 21. However, 1 plus 21 does not equal 10, so that didn't work. Well, I know 7 times 3 equals 21. 7 plus 3 is 10, so there's the one I need. So I'm going to put those numbers, a positive 7 and a positive 3, back in to my expression that I set up to create as binomials. There's going to be my factored form. I can always check by foiling. On the second example, again I ask myself, is there a GCF? No. So I will start this by putting x's in the beginning of my parentheses. So from here, I can now say, okay, I want factors of positive 12, and I want a sum of negative 8. The sign will belong to the number. Some of you will get fast at this. You will not need to make this table. Maybe sometimes, every once in a while, you will. Others of you will always need to make the table. Some of you will be able to split time about when you make the table and when you don't. So I'm going to say, 12. 6 times 2 is 12. 6 plus 2 is 8. Well, as I think about this, I realize that I'm never going to have 2 positives that are going to add to be a negative. So maybe I say, maybe they should both be negative, since 2 negatives will multiply to be a positive. So I try negative 6 times negative 2 and I get negative 12. I try negative 6 plus negative 2 and I get negative 8. I'm good to go, so I'm going to go ahead and say minus 6, minus 2, and there is my answer. Let's look at a couple more. So again, if you want to pause the video at this point, now would be a good time, example 3 or 4, or both. So on example 4, I go through my flea map or my flow map, which you can't see right now. First thing I do is I ask, is there a GCF? I say yes, there is a GCF. All these terms can be divided by 2. So I take my GCF out, leaving me with x squared plus 5x plus 6. Previous to this, when we've had a GCF, we've said we're done. Well, now that I have uncovered a little bit more information about factoring, I can't be done. I need to ask myself, can this be factored further? So I'm going to continue through my flow map. And I'm going to ask myself if this is a perfect square minus perfect square. Since it's not, I won't be able to use the special formula. Then I'm going to ask myself, is it a trinomial with an x squared that has a coefficient of 1? My answer for that is yes, so I'm going to try to factor this further by using my factor sum table, where I'm going to do factors of 6 with a sum of 5. I am pretty good at the factor sum tables, so I can get this right away. So please don't be intimidated when you see me getting the right answer where you have to go through some trial and errors. I know that 2 times 3 equals 6, and 2 plus 3 equals 5, so that works. So I'm going to put my plus 2 in and my plus 3 in. One question I get a lot is, what if I put my plus 3 first? No big deal. You can put it in either order because it doesn't matter what order I multiply in. I could multiply the x plus 3 before I multiply the x plus 2. Looking at one final example, let's say I have this situation here. I go through my table. I don't have a GCF. It's not perfect square minus perfect square. It is a trinomial with a coefficient of 1 on the x squared. So I'm going to go ahead and factor it into a binomial times a binomial by using factor sum tables, where I take factors of my last term of my constant term with the sum of my middle linear term. I need to find two things that multiply to be a negative. Well, if it's going to multiply to be a negative, that means one of them has to be positive and one of them has to be negative. So I'm going to say, what if I do negative 9 times 6? That does equal negative 54. However, negative 9 plus 6 equals negative 3. Well, what if I tried to flop my signs and say 9 times negative 6? I still get a multiplication product of negative 54, and 9 plus negative 6 equals 3. So it looks like I have what I want. So I'm going to go ahead and put plus 9 in one and minus 6 in the other. Again, it doesn't matter which I do first. And there's my final answer. Big thing is, make sure you remember to check for your GCF first. I see a lot of students make mistakes because they forget to first take out a GCF. So make sure that that's on your radar to always start there.